We have seen how you can use GeoTIFF images and CMT base maps as background images in your PC-GPS maps. If you have an aerial photograph of the area for which you have collected GPS data, it may be of interest to display the GPS feature data on top of the aerial photo in PC-GPS. A regular photo image is not tied to its geographic location. In other words, it is not geo-referenced. PC-GPS lets you register the photo so that when it is displayed in PC-GPS, each point in the image corresponds to an actual coordinate location. This registration process is called geo-referencing. Essentially, you tie a number of spots in the photo to the corresponding known GPS locations. Based on this information, PC-GPS will skew and reorient the photo as necessary, so the selected points will be displayed at or near their corresponding GPS control points. The known locations can be GPS point features, or they can be locations in an already geo-referenced map. I will show you how to register a digital image file to a set of GPS control points. To start the geo-referencing process, click on Register Photo Image from the main toolbar. Highlight the treefarm.jpg from the PC-GPS program folder. A registered photo or map image will have a plus sign placed next to its file name. I see a minus sign next to the treefarm.jpg file. This means that this image has not been geo-referenced. When I click on the Register button, the tree farm photo is displayed in the Photo section. This is part of an aerial photo of a tree farm in Corvallis, Oregon. We can see the trees, the roads, and a little church at the corner. Use File Open to open tfarmctl.ftr from your PC-GPS program folder. This loads the GPS control points into the Maps section. We will now match the GPS control points with the corresponding locations in the photo. Click the Add CP button to add the first control point record. The Pick CP by Node option is active. This will let me snap to the center of a control point when I click somewhere close to it. That's exactly what I want. In the Maps section, click the upper left GPS control point. The little red mark is now on this control point. Its coordinates will be displayed in the control points box. In the Photo section, I will zoom into the corresponding location so I may have a closer view of the photo. In fact, I have made a tiny purple dot on the photo to help me identify the control point in the photo. Now I know exactly where to click on the photo. I click the right mouse button to stop the zoom in, then click on this purple dot. The Lock checkbox is for locking the pair of GPS and photo control points in place. I will mark it to prevent changing it inadvertently. Click on the Zoom Fit button to restore the full view of the photo. Now, click the Add CP button again to add the second control point record. In the Map section, now click the lower left GPS control point. In the Photo section, zoom into this intersection here and click on the purple dot. Click on the Zoom Fit button to see two control points displayed in the photo. Let's lock this control point also. In the same way, click the Add CP button to add the third control point record. Then click the lower right GPS control point and zoom in to click the corresponding location on the photo. Lock this control point also. Click the Add CP button again, then click on the upper right GPS control point. Now I'm going to slide the scroll bar up to look for the fourth photo control point, and I will slide to the right somewhat. There it is. Click on the purple dot, lock this control point, then zoom fit to see the 4 control points in the photo. Now click the Preview button to see how the GPS and photo control points match up. Notice that the errors are quite small. To see how the aerial photo fits to an actual map, let me load the DRG image for Corvallis, Oregon. PC-GIS prompts me for the coordinate system in which the DRG image was registered. I will confirm the NAD 27 datum and the UTM Zone 10 coordinate system. I will zoom in and zoom in further into the tree farm. I'm pleased with the good fit, so I click the OK button to accept the registration. The program asks me if I wish to register another photo. I click on the No button. Once a photo has been registered, it becomes a geo-referenced photo. So now, when I use the Load Photo Image function, a plus sign is shown in front of the treefarm.jpg file name. Let's open this photo. Let's also open the DRG file for Corvallis. We can zoom in to get a better view of the tree farm. We will use File, Save As, and save this map as an FMP map file. We will give it the name Tree Farm. The next time you open this file, the 2 image topics will be there, and you may turn them on or off as you please.
When your engineer gives you the image of a drawing of your land parcel, it has no geographic meaning. To place such a drawing in your PC-GIS software program, you could first establish a few control points, and then use the geo-referencing function to register the image. You can then load the registered image into the software, and use it as a background for additional work. If you would like to place the elements of a CAD design in a PC-GIS job, then you could ask for the shapefiles, or the DXF output file, of the drawing. As the DXF output of older CAD software does not contain coordinate system information, you will need to set up a local and easy coordinate system for importing the DXF file. Both the PC-GIS software and the ICMT-GIS Pro app provide a function to let you calibrate a local and easy coordinate system against 2 known points. You could use such a system to geo-reference a design drawing in a DXF file. You could also use it for doing stakeout work. If you have an accurate GPS receiver, you could use the GPS collect function to record points to use as the known points. These 2 points should be at diagonally opposite corners of the work site. To create a local and easy coordinate system in PC-GIS, first click on Map, and then select Coordinate System. Click on NEZ, and click on the Edit NEZ Plane button. Enter name for the new coordinate system into the plane name field, such as MyNEZ. In the Reference section, enter the corresponding geographic and NEZ coordinates. In the Control Point section, mark the By Control Point option. Then, enter the corresponding geographic and NEZ coordinates. You may use the Pick GPS point option to select an existing GPS point as the reference point, or the control point, and its coordinates will be automatically entered. Basically, we have tied 2 GPS points on the worksite to the 2 corresponding points on the design drawing. The app will compute the calibration angle and scale for transforming the LLA system to the NEZ system. If you know the angle and scale for calibrating the local coordinate system against the LLA system, then, after entering the data for the reference point, you could mark the By Input option and enter these parameters directly. Now, you can select My NEZ as the coordinate system to use for working with the map. The y-axis of an NEZ plane will be displayed on the screen as pointing up. This is generally different from the direction of the north arrow in mapped view. The NEZ x-axis will point to the right. To use the NEZ coordinate system that you've created in PC-GIS in your CMT-GIS app, you must copy the user_pla.sys file to the Documents folder of your app.